somewhere out there right now, a black hole is waiting silent, invisible patient. And the terrifying truth is, there are roughly 100 million of them in our galaxy alone. So let's ask the question nobody really wants to answer. What actually happens if one comes for us? Because here is the thing most people don't realize. You don't need a monster-sized black hole to wipe out everything we've ever known. A black hole no bigger than a pinhead, literally 1 millimeter across, could obliterate Earth if it got close enough. That is how insanely dense these things are. Their gravitational pull doesn't care about your size. It only cares about proximity. And proximity in this case is a death sentence. Now, before we get to the part where everything falls apart, let's understand what we're actually dealing with. There are two main types of black holes worth knowing about. First, stellar black holes, the most common kind. These are born when massive stars, anywhere from 10 to 20 times larger than our Sunday, burn through all their fuel and collapse violently inward. The explosion is called a supernova, and what is left behind is a black hole roughly 16 kilometers across. Small, dense, and incredibly dangerous. Then there is the other kind. The kind that makes stellar black holes look like a puddle next to an ocean. Supermassive black holes. These have diameters roughly the size of our entire solar system and contain the mass of over 1 million suns combined. One of them, called Sagittarius, sits right at the center of our own Milky Way galaxy. Right now, as you are reading this, thankfully, it is far enough away that we're safe. For now. But let's say something changes. Let's say a black hole begins drifting toward us. What is the first sign that something has gone catastrophically wrong? The answer is the event horizon. And once you understand what it is, you'll never think about space the same way again. Think of the event horizon as a boundary, a point of no return. Cross it, and the laws of physics essentially issue you a one-way ticket with no destination. To escape from beyond the event horizon, you would need to travel faster than the speed of light, and nothing in the universe does that. Not even close. Once you are past it, you are not escaping. So here is how it plays out for Earth. As our planet edges closer to the black hole, the side of Earth facing it begins to feel a dramatically stronger gravitational pull than the side facing away. This difference, this uneven tug, is where things start to unravel. First, our atmosphere gets peeled away. Layer by layer, the air we breathe gets vacuumed off into space. Then the surface itself starts to crack. Enormous chunks of rock and ocean begin tearing away from the planet, spiraling toward the black hole in a slow, catastrophic unraveling. But if Earth somehow settles into an orbit around the black hole rather than falling straight in, we'd face something called tidal heating. The uneven gravitational forces would constantly squeeze and stretch our planet like a stress ball that never gets a break. That constant deformation generates friction deep inside the Earth's core, superheating it beyond anything we've ever experienced. The result? Earthquakes that never stop, volcanoes erupting across every continent, tsunamis swallowing coastlines whole. It wouldn't be the end of the world. It would be the world ending in the worst possible way. Slowly, violently, and completely. And then comes spaghettification. Yes, that is a real scientific term. And no, it has nothing to do with dinner. As Earth, or anything, really, gets close enough to a black hole, the gravitational difference between the near side and the far side becomes so extreme that it physically stretches matter vertically while compressing it horizontally. Imagine being pulled from both ends while simultaneously being squeezed from the sides. You'd go from a person to a long, thin strand of atoms in moments. For a stellar black hole, this process begins several hundred kilometers before the event horizon. For a supermassive black hole, it actually happens inside the event horizon, deep within the point of no return, where the physics we rely on daily starts to bend and break. Either way, the outcome is identical. Everything, people, planets, stars, gets reduced to a ribbon of individual atoms stretched out into the void. But Earth wouldn't suffer alone. The moment a black hole enters our solar system with enough gravitational influence, the delicate balance that keeps our planets in their orbits begins to collapse. Planets that have followed the same path for billions of years would start drifting, wobbling, and eventually colliding with one another. Jupiter crashing into Saturn, Mars tumbling out of orbit, Mercury falling into the Sun. And if that wasn't enough, our asteroid belt, home to over 552,000 known asteroids, roughly 200 of which are larger than 100 kilometers across, would be sent hurtling inward toward Earth. One direct hit from an asteroid that size ends human civilization before the black hole even gets its chance. So there is a very real possibility we'd be wiped out by a rock before we ever got close enough to be stretched into cosmic spaghetti. It is hard to say which fate is more terrifying, even if you somehow survived all of that. The atmosphere loss, the tidal heating, the asteroids, the spaghettification, you'd still have one more enemy to contend with. Radiation. As matter gets pulled into a black hole, it forms a swirling disk of superheated gas and debris called an accretion disk. This disk generates some of the most intense radiation in the known universe: X-rays, gamma rays, energy levels that would cook through any shield, any suit, any structure we've ever built. There is no bunker deep enough, no material strong enough. Now, here is where things get genuinely strange. Some scientists have explored the idea that a star could theoretically share its gravitational influence with a black hole, creating something called a circumbinary system, where a planet orbits both. But even in that scenario, the tidal forces involved would make any planet in that orbit completely uninhabitable. And at some point, the planet would either get flung out of the system entirely or swallowed, by the sun or by the black hole itself. There is no version of this story where we win, but here is the question that keeps physicists up at night. What if someone survived long enough to cross the event horizon? What would they actually experience on the other side? The honest answer is, we don't know. And that might be the most unsettling sentence in all of science. No information escapes a black hole. Not light, not signals, not data. Whatever happens beyond that boundary is completely invisible to us. But the theories are staggering. The laws of physics, gravity, light speed, the behavior of atoms, may operate in entirely different ways inside a black hole. Some physicists believe the interior could connect to another region of space entirely. Others suggest the conditions might give rise to something like a parallel universe. And then there is the theory that stops you cold the moment you really sit with it. What if we're already inside one? What if the universe we think we understand, the stars, the galaxies, the space between everything, is itself contained within a black hole of unimaginable scale? What if the boundary we can never see beyond isn't at the edge of a black hole somewhere out there, but wrapped around everything we've ever known? We don't have the answer to that. Not yet. Maybe not ever. What we do know is this: black holes are not just distant curiosities. They are the most powerful objects in the universe, and they follow rules we are only beginning to understand. The universe is under no obligation to keep us safe. It never has been. So the next time you look up at the night sky, remember, some of those points of light aren't stars at all. Some of them are waiting.